Now our guest speaker, Davide Bettio. The talk title is AtomVM, Where We Are Now and Where We Are Going.
こんにちは。
こんにちは。
So, I will thank you for also for the help for translating the slides. I hope this will make this presentation also easier for everyone. But if I explain something in a way not clear, just raise your hands. And I like to have some kind of conversation also, so if you have questions at the end or anytime, just let me know. And before starting, I would like to briefly introduce myself. And in order to understand the project, it's important to give some background about me. And I started very long time ago with embedded devices. When I was a kid, I started to program, and then I started to combine programming with electronics. And so that is the reason I love working with this kind of projects. Also, I love open source software, and this also came from a very long history, because I started work on KD Plasma project more than 20 years ago now. And also later, years later, I discovered Elixir when I was at my company working on an IoT platform. And when I discovered Elixir, I fell in love with Elixir. And so, combining everything together, we have AtomVM. And last thing, I love hiking, but I have a lot of different hobbies. And also somehow this can be combined together, because some of my projects are about also hiking, and maybe I can discuss about this later. And let's give some another disclaimer about this presentation. I'm not going to introduce AtomVM. It's not an hands-on. I would like there will be something very awesome in the future that will be a hands-on event, a workshop, and you can find more information with that QR code. I would like to give you this evening a different perspective. I would like to explain where the project is moving, what did happen recently, and where we are going in the next month or maybe years. And that is the reason I'm giving you this presentation. And this is the very short summary of the agenda. And I think we can start. And anyway, I will make a very short introduction, because still it is important to make introductions. And as you may know, AtomVM basically allows you to run Elixir code or Erlang code, or basically anything that is aimed to the beam on devices that are not meant to run the beam. Because if we think about a device like this device has 8 megabytes of RAM or 16 megabytes of RAM. Some other have half megabyte of RAM. And so they have so few resources that they cannot run the beam, but still running the Elixir programming model can be very valuable. If we think about concurrency, about a functional language, about writing tests, about all the good practices that are coming with Elixir, also supervisors, Gen servers. We really want to have this stuff on devices that are very resource constrained. So for this reason, I created AtomVM. I still remember today that I started to work with AtomVM. I was thinking about, oh cool, there is the ESP32. The ESP32 has internet connectivity, has support for Wi-Fi, have multiple cores, have a lot of features, but I would love to use these features using Elixir, but I cannot use them. So I created AtomVM in a very crazy rainy day. And this is AtomVM basically in a few words. And so, yeah, I love Pallas cats or Manuel Neko, and they are very, very cute. And 2025, I would like to say it has been a very amazing year for AtomVM. It was a lot of things happened at the same time, and I would like to share the updates with you. So, one of the brightest news about 2025 was Popcorn project. That is not about embedded, but still very interesting because it is about using a virtual machine made for a constrained environment that can be a web browser for allowing running Elixir in an unexpected place, because as we all know, Elixir is very good for backends, but thanks to Popcorn we can also use Elixir for the front end. So it's a different thing, but still something very, very close to the original idea of AtomVM. And we didn't work only on Popcorn, of course. A lot of improvement and landed to make this possible. But it's not just about Popcorn or all those general improvements. And we have something very cool that happened, that was compatibility that has been improved. We have distribution, and we have JIT, and much more. And so let's start about distribution. You probably know what is distribution, but also I will give you some ideas about how it can be used. At the moment, AtomVM, starting from 2025, can be part of a Beam cluster. So you can have a cluster with some nodes that can be running NERS, and some other nodes can be running AtomVM. So you can have processes that communicate between them. And we have support for all the usual stuff you are used to use, including APMD, for example. You can use any data type that you already are using. You can have some I/O through one node to another node. So we have a lot of advanced features that are available. We can even have a remote shell running on a device. You can connect a remote shell. Here in this case, you need some additional modules that we don't ship usually, but it is possible, of course. And also there is a question, why do we need distribution on such devices? And the idea is very interesting. The idea is that you can solve different problems. For example, you can have some kind of hardware machine or some kind of machine that has some kind of like a nerves that controls some very complicated stuff, but you can have some low power domain that maybe stays always on, so you can switch on nerves and CPUs that consume more power on demand. Maybe you can use AtomVM for all the I/O stuff that maybe it's more complicated on Linux, or you have some specific requirements, so you can use a microcontroller as an expansion board. This can be useful, by the way, also, let's say, also for robotics. Maybe you want some kind of robot that has nerves, but has some parts that are independent, running, still running Elixir. So there are plenty of possibilities, and the message here is that when we introduced distribution, we didn't decide why you should, we didn't decide how you should use it. We decided that it is interesting also for those simple devices. So it is up to you to create new, solution, new ideas that make use of Erlang distribution. So I'm here to say now it is possible. Let's use it. Let me know if you have any kind of scenario you want to use it. And Also, since we are, by the way, talking about embedded devices, compared to the standard LN distribution, we are also aiming specific protocols that you don't have usually on, on the regular beam, like running Erlang distribution on a E2C connection, or maybe on SPI or a UART serial line. So you can do some very embedded stuff. And the next thing is that happened this on 2025 is just in time and ahead of time. It just as an introduction, AtomVM used to run unmodified beam files. So you compile something with Elixir compiler, or maybe Erlang compiler, or Gleam, or whatever, and you generate some beam files, and there is a process that packs them into an AVM file, but they are still beam files. And with just-in-time or ahead of time, they can be translated to native code. This can be useful for some performance reasons. So you can have ahead of time compilation on your machine, or maybe just in time on the target processor. And we support already a number of architectures. So basically we support the architecture used on ESP32 or on different host machines like x86 or Mac that are 64-bit ARM. And as I mentioned, we have two different modes that can be used, and the two different modes are the answer to different problems, to different needs. So you can use ahead of time when you want to use native code on a device that has not enough RAM, or you need more RAM for running your program, so you don't want to run just in time on the device. So you can have some kind of CI or just use it on your machine to generate alternative code that then you ship to the device. So you do some kind of compilation, let's say, and so the device will execute native code later. And in this case, you can also have a special build of AtomVM that doesn't have just-in-time engine, that maybe doesn't even have the interpreter, so you save space on the flash and you just ship the compiled code. But also we still support more dynamic modes. So if you want to run some code with better performances on a device that is able to run a just-in-time compiler, you can just ship the beam file and you can just have it compiled on the fly on the device. So this is pretty new. This has been added in November to AtomVM roughly, and we are still adding last parts to make it easier to use, but it is already available on the main branch. So if you want to give this a try, it will be very nice. And still about, yeah, this is what well, next topic, let's say. So this is what we support at the moment. I would like to share this with you because I want to let you know what we can do right now. And the project has improved a lot over the time. And as I mentioned, 2025 has been the year of compatibility, because we had a lot of work to make certain use case like popcorn possible. And in order to do this, we improved a lot of the standard library. We added a lot of functions. So everything is in a better state than in 2024. A lot of work has been done. And so, for example, a lot of the modules that you usually use are available right now. And one of the questions is, do you support Gen Server? Yes, we do support Gen Server, and pretty well, and all the other Erlang abstractions. And still we miss some parts, and the parts we are missing are very specific. So we support a very vast number of functions, but the parts that we are leaving outside are likely parts that you are not going to use, because, for example, if we think about CPU topology, it's something very specific to some very high-end machines that you are not about to think about this when you think about devices like ESP32. Also, we are leaving out deprecated functions. So if your software relies on some deprecated functions, it might not work on AtomVM. So I suggest using latest functions for doing stuff. Still, we have some missing parts, so we are always looking for contributions because there is still space for improvements. But again, it is a very impressive amount of features that we can make it fit into very small devices. And so the question is how we can trust you that this is enough for me. And this is a very good question. By the way, this is a Palace cat, if you are wondering what he is. And so, as a demonstration to show how it can be, how complete is AtomVM right now, is that we are able to run the Elixir shell, and the Elixir compiler on an AtomVM itself. We didn't try to bootstrap the whole project using just AtomVM, but I think we reached the self-hosting target. That is something amazing. That means that project can be used also for other complex applications, because in my mind, a compiler such as the Elixir compiler is a very complex project. So if you think about that, I think that other complex projects can be executed. And speaking of popcorn, because what I shown you was a popcorn demo, popcorn was, as I mentioned, one of the greatest additions of 2025, and this has been made possible in a very simple way, by the way. And there were other attempts of doing the same thing in the past, but they didn't succeed because they've been probably too much complex. And the idea behind popcorn is very simple. The idea is that you have a very simple virtual machine that takes few kilobytes of space, such as AtomVM, and you can compile it into WebAssembly. As soon as you get it compiled to WebAssembly, you are able to run any kind of application on the browser, and I mean any kind of Beam application on the browser. So what has been done with popcorn has been crafting a library, a set of tools that helps you shipping the application in a very easy way. So you have all tasks for shipping your application. And thanks to this, we've been able to get some very, very interesting ideas. For example, one of the first idea that came in life with popcorn, and probably was one of the initial goals, was enabling testing, trying Elixir without installing it on the PC. So the idea is, I want to try it, I don't want to install it, and thanks to popcorn, you can just go to a certain website and start poking and trying Elixir without any other effort. And that is the reason we did a lot of work, by the way, for making possible running the compiler, because you need actually the compiler for running the two examples. And also, there are some more advanced ideas that are still into making. For example, one of the ideas is that you can have Phoenix Live View running on the backend, but what about running part of Live View also on the front end? And what Software Mention did was enabling having, like, let's think about some error checking, like if you type into a field, you want it checked on the front end, and you want it even if the backend is not responding, or even without having some interaction with the backend. So the idea is that you can have the same concepts of Phoenix Live View on the front end, and this has been made possible using all the technology that has been introduced with Popcorn. And 2026. May I ask before going ahead some water, by the way? Some water? Can I have some water? Or can I, do we have? Oh, a minute. Sorry, I feel my voice fading out, and I already know that after a while that I talk.
Davide, which is it? Water or?
Anything, thank you very much. But if you have any question, it is the right time for asking a question about 2025, because then I will be moving to 2026. Yes?
So you mentioned about the JIT. How hard was it to add it? And did you use anything like ASM JIT, like the same thing as the OTP, or something different?
Do I need to repeat the question for recording there, or was it clear? Oh, can I repeat anyway? The question was how complex it was to add the JIT to AtomVM. And actually, we used some kind of very different approach, and that was very simple, because instead of writing the just-in-time compiler in C, that can be very tricky and very boring, it has been implemented in Erlang. So everything is done using pattern matching and everything as we have already in our toolbox. So actually, the just-in-time compiler is very simple. So it is also interesting because let's make some kind of digression. One of the purposes of AtomVM is like a side purpose, is that the project can be understandable also from people that are studying. So if you want to study how a virtual machine works, or how a just-in-time compiler works, AtomVM can be a good example, because everything is done in a pretty understandable way. And in this case, the just-in-time compiler are a few thousand lines of code. It's not like a monster C library. It's very simple. So we are not using ASM JIT. So basically, we pattern match all the bin code, we emit some chunks of native code, and that's it.
Thank you.
Any other question? I think we can move with 2026. So 2026. So as I mentioned, the idea about what we did in 2025 will be, as soon as possible, will be tagged as 07. We've been keeping 06 alive for like, I think 2 years, because we have this kind of stable branch, but it's time to make things, I mean, a new release, but also I would like to release more often now. And the idea is that V07 was about improvements to the virtual machine. It was about, as mentioned, to improvements to the core. What I aim for 2026 is releasing what we did in 2025, but also starting to add new stuff. And the new stuff will be more likely about hardware stuff, hardware support and platforms. And well, as I mentioned, this is kind of a recap. Oh, nice. Great. This is kind of recap of what has been done for 07. there are still some parts that will be done in the next weeks, I think. Like we are going to improve error handling so we can print better error messages. Bit strings maybe are going to be supported also with 0.7, maybe not, but quite likely. There are a few other improvements floating around for optimizing flash memory usage and stuff like that. But I think we are mostly done with this release cycle. And talking about 0.8, as I was mentioning before, we are going to focus on hardware platforms. And there are some obvious questions about this. And the obvious questions are, what about Zephyr maybe? Or, yeah. And here we are with Zephyr. And Zephyr is very interesting because I don't know if anyone of you knows Zephyr, but maybe I can introduce it briefly. Zephyr basically is one of those real-time operating system plus abstraction layers that allow you to write using C language code for different devices, because ESP32 is a very happy world that has ESPDF that is very convenient, has a lot of functions, a lot of abstraction, but it is specific just to ESP32. But we have more devices around. So the idea is extending the number of devices that we can target with AtomVM by using Zephyr as an abstraction layer under AtomVM. So the idea is adding support for this platform, and this will be very, very cool, by the way. There were some attempts, there were some previous attempts to get this done. They didn't succeed for really simple reasons, because there are some tricky parts that have to be done, but they are not too much complex, and the main issue was, lack of time and priority. We've been more into the core VM itself before expanding to more platforms. And I think that we are now coming to a moment that it's time to think about expanding to more platforms. And speaking about more platforms, I think that as soon as we support Zephyr, we'll be able to target a vast number of different manufacturers and devices where we cannot run. And likely the real limit will be in the future the available memory. That is still a constraint. We still need, we can run with 32 kilobytes of RAM, but I really suggest having like 64 kilobytes of RAM when running AtomVM at least. So some devices can actually run Zephyr, but they don't have enough resources. But as soon as you have resources, you will be able to run AtomVM on different targets, and so that will be very, very cool, I think. And still, there are other alternatives to Zephyr. The other alternative is NATEX, and basically they are kind of overlapping solutions. They still do the same kind of stuff. We would like to add also support to NATEX after Zephyr, because it gives some additional options. So maybe some specific boards have a better support with NATEX, or maybe some native components that you might want to use or integrate have better support with NATEX. So we would like to have the best support around adding more platforms and more choices. Still, I think that it will be after Zephyr. And the other topic about 2026 will be in nerves. That is one of the biggest issues right now around with Elixir and AtomVM, because when you are working with AtomVM with Erlang, probably you are fine using our APIs because there is not equivalent in the nurse world. Maybe it's not so common. But if you are coming from Elixir, where maybe you have some ready drivers, maybe you have some kind of already done project that runs on nurse. Maybe if you have some kind of nurse support also on AtomVM, you can transform your project. You can port your project to AtomVM in an easier way. So nerves will be one of the targets. I mean, having some sort of compatibility with nerves will be one of the targets for this year. And we don't have all the ideas right now about how it will be, because it's still something that has to be explored. And also I'm speaking to you because I'm looking for feedbacks. So if you have any feedback about how to do this in the proper way, I'm looking for them. Also because we didn't start yet this work, so early feedbacks are always valuable for making next developments better. And probably we start with basic, all the basic peripherals that are more common. Still, there are some parts that are we need to figure out how to make this the best way. And the next part about improvements that are on the radar for 2026 are about, the development experience, because right now we have some good tools like AtomVM allows you to even install AtomVM on a fresh new device. You can have a number of automations that are very convenient, but what we really want is not a good user experience. We want an excellent user experience, because what I really like about the Elixir world is that it has an excellent developer experience, and we want this as well on AtomVM. So also in this area we are looking for improvements, and we are looking for suggestions or feedbacks. And one of the points that we are about to cover is how to remove from the equation all the custom builds. We want to provide you some tools that allows you to completely forget about ESPDF and C compiler and all that stuff. We want to provide something that you can just type a few commands that like mix, do something, and you get the suitable image on your device. I'm saying this also because, as you may know, there is not just AtomVM, but there is also floating around AtomVM plus maybe the audio component, or maybe AtomVM plus the AtomGL component for displaying stuff. Those are native components that are not part of the main project. So our idea is providing something that allows you to have all this addition out of the box without having all the development, the C development environment on your machine. So we are also working on this. And yeah, I want to also this is going to be, we are going to move away from what's going next, and I want to do this kind of sort of off topic, because I know that AtomGL has gained some interest, because we all have displays and we want to use them. And for example, I brought one of the displays I was talking about. It is the e-ink color one that runs with AtomGL, so it is one of the supported devices. Now I'm turning it on, and after a while it will refresh to something better. And basically the idea about AtomGL is that you don't have to worry about, I have this display, I need a specific library for drawing stuff to the screen, or this screen has some specific color profile, is monochrome, RGB, but RGB with fewer colors, more colors, whatever. The idea is that you have just one driver and this driver is able to drive all the displays that it supports in the same way. And that is the basic idea. And in order to achieve this, we are using a declarative approach. You don't tell to what you want to drive. We are going functional. We love functional approach. So we rather want to focus as soon as you do all your function. We want to focus on declaring what we want to see. And so the idea is that we just add to our Gen server a list of items we want to display, and there will be a specific tuple that we can use as a return value for pushing a screen update. And doing this, you can have your scene displayed with the AtomGL on the screen. And again, as I mentioned, you never worry about the screen, the kind of screen you have, or doing some imperative style drawing. And also, this has some, also this has some additional benefits, because you don't have to have everything stored into a gigantic buffer. Everything is stored. I mean, everything is rendered scan line by scan line, and also when you want to, working with items feels very natural, because if you want to add something on top, it means that you just have to prepend to list some kind of items that is displayed on top of everything else you already have. So it feels very, very natural when we work with a list here. And yeah, so after all this, in the meantime, the screen just updated. So this is a good example, by the way, of, I don't know, I can show it you later, but this is a very good example about what you can do with AtomGL. Here you have everything. This kind of graphic menu has been designed for a regular LCD screen, but I'm running it now on a e-ink, color e-ink device. And by the way, AtomGL also takes care of doing alt dithering. So even if you have a monochrome device and you try to display a color rectangle, it will choose the right pattern for you. So you will have some very nice shading and dithering, and everything will be visible anyway. And yeah, going back to what's next. And so what we are finally aiming to, I think that we are really pretty ready to production. But what we are still missing is when we say 1.0, we think about semantic versioning. And when we think about semantic versioning, it means that what we really miss is that we need to stabilize the API. So things might change in the future still for the next few versions. But eventually we want to reach a point when you will not have to worry about what we changed across different versions, because it will be very stable and in terms of API. And this is what we are doing right now. So we are moving to thinking to 1.0 in a very progressive way, but with this a stabilized API, so you don't have to worry about this kind of stuff. And okay, and just I would like also to say thanks to some sponsors that helped made this possible, that were Dashbit this year and Software Mansion. And basically most of the popcorn work has been done with excellent engineers from Software Mansion that joined the AtomVM team and built something on top of it. And a project such as popcorn is not possible just in such a short time. just doing it in the free time. And this sponsor made this possible. And talking about the future, also about what I'm going to do with this project, I'm going to work starting from this year full-time on AtomVM. So this is kind of a new challenge for me, and I will of course need still some help, but I would like to start, as I mentioned before, moving with a faster rhythm. I would like to release more often, to answer in a shorter time to issues and stuff like that. So I think that the entire project, also for this reason, is moving to a new kind of age. We are moving to the production ready age. And yeah, as I mentioned, everything is possible also because we have a lot of contributors. And I would like to give you these links for, if you want to start or join us. We have a Discord channel, we use also Telegram. We have a very rich documentation that can be improved, of course, but there is a lot of documentation already, and of course the usual website. And also, of course, this is my contact, and also if you want to sponsor my work on AtomVM, this is the link to the sponsor GitHub page. And that's it.